Okay, dilutions. So, we've been talking about with molarity that in order to increase or decrease the molarity, we can either add or take away solvent, right? We can add more or less water. And we know what this term means. To dilute something means, in general for us, it means to make it less concentrated. Or, in our terms, for chemistry, we're going to decrease the molarity, right? When we dilute something. It's a pretty straightforward idea and concept, but some of the problems can be trickier. So what I want to do is we're going to go on page 7. We're going to do this entire page together. Actually, no, we're going to do numbers. We'll do number 1, 3, and 5 together. So let's go ahead and do number 1. Number 1 says, if I add 25 milliliters of water to 125 milliliters of 0.15 molar NaOH, what will be the molarity? Well, there's an equation for dilutions, and it is this. The molarity of the first thing times the volume of the first thing equals the molarity of the second times the volume of the second. Okay? So, M1V1 equals M2V2. Some people like initial and final. Whatever. It's like, alright? It does not bother me one way or the other, just like with gas laws. So, M1V1 equals M2V2, right? Well, you were told originally that the molarity of the sodium hydroxide is 0.15 molar. You are also told for that 0.15 molar, you have what volume of it, and that amount was 125 milliliters. Now, here's what's cool. Just like in gas laws, as long as your units match on both sides, you're good. So since you have milliliters here, the volume here will also have to be in milliliters. Or you could have changed it to liters and have liters and liters, whatever you want to do. So you want to know, you're going to add 25 milliliters onto this. So your new volume, when you add 25 milliliters, is 150 milliliters. And now you want to know what the molarity is when you do that. Well, you do the math on this. 2 sig figs, 3 sig figs, 2 sig figs. So you get an answer, molarity equals. You round it off to 2 sig figures and you get 0.13 molar. That's the answer for number 1. Alright, let's go to number 3 now. Number 3 said, okay, well, how much 0.05 HCl solution can be made by diluting 250 milliliters of 10 molar hydrochloric acid? So here we have 10 molar. And originally you had how much of it? 250 milliliters of it. And it says how much of 0.05 molar can I make? Well, you're going to solve it for volume. Well, you know what? For this one, I probably would say 1 significant figure because of the 10. So you do your math on this and you get volume equals, and with 1 significant figure, the answer is 50,000. It's milliliters because they have to match. There's your answer right there. Okay? Which brings us to number 5. Number 5 is the hardest I can make it. So diluting is pretty easy, isn't it? But number 5 is where it gets a little tricky because number 5 says, okay, I have this, I want this, go ahead and make it. So, how much water would I need to add to 500 milliliters of a 2.4 molar KCl solution to make a 1 molar solution? So, M1 V1 equals M2 V2, right? So here we go. 2.4 molar times a volume, and that volume is going to be 500 milliliters. That equals 1 molar. So we're going to take it from 2.4 to 1, and what volume would it be of water? Well, you do the math on this. 2 sig figs, 1 sig fig, 2 sig figs, right? So therefore your answer can only have 1 significant figure, but you know what? To heck with that. We're going to make this 500 decimal place. So, yeah. make it 500 decimal place milliliters. When we do this then with two divot figures, the answer is 1,200. Now, here's the thing, right? Here's the part you got to think out, though. You see, this is the final volume of the solution right here. But you started with 500 milliliters already in the container. So as such, how much is it? 1,200 minus 500 equals 700 milliliters. And that is the actual answer. Go ahead and do a couple problems now on page 8. Let's start with a simple one. We'll start with 1A. Again, we are on page 8. So, it says, determine the concentration for each of the following mixtures. Equal volumes of 3 molar KCl and water. Equal molars. Or equal volumes. So you don't want to say 5 milliliters. What the heck? So, M1 V1 equals M2 V2. So I'm going to say we have 5 milliliters of KCl and 5 milliliters of water. Well, you're told in letter A that this is 3 molar KCl. And I told you that you're going to have 5.0 milliliters of it. That is going to be equal to the new molarity when you put in 5 milliliters of water. Well, I could have said they'd be equal, right? Well, the total volume then would be 10.0 milliliters. You solve this for M. 2 sig figs, 2 sig figs, 3 sig figs. Therefore, there can be 2 in your answer. And the answer is 1.5 molar. At the bottom, you're going to find in random order plus 1. You'd go find 1.5. And you'd cross off for units and M for molar. Let's do another one. Let's see. Let's do 1E. It says 1 volume of water and 2 volumes of 6 molar KCl. So, now it's 6 molar KCl. It says 1 volume of water and 2 of the KCl. So if we keep 5 milliliters as our norm, 2 volumes of this would be 10 milliliters, right? 2 of them, because if they're 5 each and we get 2 of them, equals molarity times the volume when we take the 2 volumes of this and the 1 volume of water. So 10 plus another 5 for the water is 15 milliliters, right? So, significant figures are determined by the 6.0. You figure this out and you get 4.0 molar. Let's go ahead now and do another one. Let's do a hard one. Let's do a couple of very challenging problems. There are a couple of very hard ones on page 8. Okay? Letter A is a particularly difficult and challenging problem. I'm probably going to do it in class, but here we go. So, this is page 8, 3A. It says, use dilution equations to determine the concentration of the following mixtures. When you have 2 things and you're putting them together, you have to follow this. M1 V1 plus M2 V2 over V1 plus V2, or total volume. So V total. What does that equal? It means the molarity of the total solution, or the whole. So in this one you're told you have 45 milliliters of 3.6 molar solution. So 3.6 molar times 45 liters of it. Plus 71 liters of water. Well, what is the molarity on water? It's 0 molar. It doesn't have one. It's water. And there are 71 liters of it. Well, total volume would be 45 liters plus 71 liters. 2 sig figs, 2 sig figs, 2 sig figs, 2 sig figs, 2 sig figs. Therefore, you do the math, you round it to 2 sig figs. The answer is 1.4 molar. Let's go ahead and do 3B, and then I'll set you guys free. By the way, 3C is going to be another example of this, where you got to do 2 of them. So 3B says 250 milliliters of water and 47 milliliters of water. Okay, so you could do this the same way as you did it up here, or you could do M1 V1 equals M2 V2. You're going to get the same answer either way. So here we go. 2.8 molar times, let's see, you got 215 milliliters of it equals, you're adding 47 milliliters of water. So now you want to know what the molarity is when it's 262 milliliters. You do the math, and molarity equals 2.3 molar. Let's take a look at some of these problems. I think you can do the rest of these on 3. You can do these on 4. Number 5, no problem. Which brings us to number 6. Let's go ahead and do a number 6. So we are now going to be on page 9. We're doing page 9. Let's go ahead and do number 6. And we'll do A. It says, what volume of 2.5 molar KCl must be added to 37 milliliters of 6.0 molar KCl to make the following? So again, this is one of those where you need this M1 V1 plus M2 V2. You're putting 2 things together over the volume total equals the molarity total. Now you just got to plug everything in where it goes. So you're told it's 2.5 molar. And it wants to know what volume, so there's your V, plus, so 2.5 V, plus 6.0 molar times 37 milliliters. Now this is going to get funky, because on the bottom here, you're also going to have this, 37, right, milliliters, plus V, that volume. So this volume, or this V, ends up in this thing on 2 places. When we do our math, it's going to get a little tricky because of it. So what you end up doing is equals 1.5 molar. I told you right here in letter A that the total is 1.5 molar. So here we go. So you multiply both sides by 37 plus V. So distributive property makes you do that. So you end up with 2.5 V. I'm taking out the variables right now. Plus whatever 6.0 times 37 is. And I'm 2.5. Plus 222. Where'd that come from? First of all, this is 2.5 times V. 222 is 6 times 37. And that would be equal to, now remember, this is distributive property, so 1.5 times 37, which I believe is 55.5, and it is, plus 1.5 times V. Okay, in algebra, what we do now is we combine like terms. So you subtract 1.5 V from both sides, 1.5 V, and you get 1.0 V plus 222 equals 55.5. Anybody see an issue here? Well, you're going to subtract 222, subtract 222, and you get a negative answer. So your volume is equal to a negative, I don't know, it's like negative 170 something, whatever it is. No. The answer here, therefore, is, you can't have a negative volume, so the answer is not possible. Now, you might find yourself looking at it being like, wait a minute, that's funky. But here's the thing. So, this thing is asking you to take 2.5 molar something and 6.0 molar something and get something smaller, 1.5 molar. Well, that doesn't make any sense at all, because if you were to mix something that's 2.5 and something that's 6, if you just took the average of them, your average should fall somewhere between 2.5 and 6. So it makes no sense that 1.5 is possible. Therefore, does this answer make sense? Yes. Now, 6b is the exact same process. And it is possible. I wanted to do this one because if you read the directions at the top of the page, it says one of the problems isn't possible. It's 6a.